learning about how mirrors work in reflecting light, why they are so important, learning about reflection, and much more. For the duration of our research, we plan on including the different types of mirrors, concave and convex, curved and plane, the law of reflection, application of mirrors, and the different types of images. As early as 600 BC, former mirrors were beginning to be created by humans, and they were served their first purpose of reflecting. From our research, we found out that in Mesopotamia, Iraq now, as well in Egypt, mirrors were being produced from 4000 to 3000 BC. According to Joseph Castro, South and Central America also started to create mirrors about 1,000 years later from a more polished type of stone. Later, makers of mirrors from China and India created them from bronze. This shows that throughout time we have become more sophisticated with the material in which we make mirrors with, from obsidian to copper, bronze, silver, and gold. The glass mirrors we have and seen today were brought up in Germany in 1835. Justus von Liebig had came up with the process of applying a thin layer of metallic silver to a side of a piece of clear glass.
You change the slide and then people like Euclid, Ptolemy, Herschel, Maxwell, and Hertz made major discoveries and contributed greatly back in the day. Euclid described the law of reflection around 300 BCE. He pointed out that light travels in straight lines and reflects from the surface at the same angle it started at originally. Light happens to travel in rays which are distinct, like waves. And then Ptolemy said that refraction is how a ray of light ends up changing direction and how it travels between different mediums. William Herschel looked into the question of finding out how much heat was stored by the different colors of visible light. And then in 1867, James Maxwell thought that there should be light with longer wavelengths than infrared light. Hertz had created an experiment to prove that there's actually an existence of waves that Maxwell had assumed by creating radio waves. And then he changed
Ptolemy, by the way. Yeah.
And then for how mirrors work, when rays of light or photons coming from an object strike the smooth surface of a mirror, which is made of a metal sheet and glass, they bounce back at the same angle, creating an image, and these reflected photons appear as a mirror image, and that's just a picture demonstrating it. And then for our current research, we decided to look more into the Keck Observatory, which is on the Big Island of Hawaii and sits on top of the dormant volcano. It's 4,207.3 meters high and is the highest point in all of Hawaii. By being this high up, there are no mountain ranges that are nearby that will impact the upper part of the atmosphere. And the observatory is home to the biggest optical and infrared telescopes in the entire world. The two telescopes are called Keck 1 and Keck 2. The Keck 2 telescope was the first one to have a flexible optic system be put in place, which allowed the telescope to be able to adjust to how shape the mirror appeared according to fluctuations in the atmosphere. And then the observatory and the professional astronomers have been able to learn a lot of information about our atmosphere from the optic system. The atmosphere can easily cloud what we see of the stars, which end up creating difficulties for astronomers who focus on this work. To give an idea of what the astronomers have been working and finding information about from these telescopes is that they've been able to get a great idea of how the universe evolved to how it is today, how galaxies formed, how much the expansion rate of the universe has varied over time, and also how old stars in our galaxy are. Here's a video just showing the observatory.